Hello everyone. Waveform update rate becomes more and more important for a digital oscilloscope because it allows users to clearly observe the burst or fast-changing waveforms. Instek's entry-level DSO GDS 1000B equips with high waveform update rate up to 50,000 waveforms per second. We will show you why GDS 1000B is able to reach higher waveform update rate. For the conventional DSO design, CPU has to handle all tasks. But for GDS 1000B, the new VPO circuit is employed to handle graphic processing tasks in parallel with CPU at the same time. Now let's compare the difference between GDS 1074B and DS1074Z. This demo board GDB03 is used to generate a mixed signal, which includes a continuous signal and a burst signal. Both oscilloscopes have the same setup parameters. First, we will compare burst waveform capture between GDS 1074B and DS1074Z. Let's observe waveforms of GDS 1000B. You can see there are stable signals and a burst signal. Now let's take a look at DS1000Z. Its waveform update rate 30,000 waveforms per second. Here we can see only stable signal, but the burst signal is rare to be seen. These results show that the GDS 1000B can capture and display the burst signal clearer than that of DS1000Z due to the high waveform update rate. Next, we are going to compare waveform update rate by FM signals. Again, GDB03 is used to generate a FM signal. We can clearly see that GDS1074B reveals fast waveform update rate and red FFT display. For DS1074Z, it is obvious that both waveform update rate and FFT display are much slower. From the above instances of burst and FM signal measurements, the transient or fast-changing signal can be better captured and displayed on GDS 1000B because of its high waveform update rate. This provides the engineer a very handy tool to capture and analyze the higher and higher speed signal in contemporary electronic devices. Thank you for watching this comparison video.